In this experiment, you'll be looking at the rate of a reaction. The rate of a reaction is a measurement of how fast the reaction happens. Something with a higher rate would happen faster and therefore would have a smaller reaction time. Likewise, if you have a small rate, the reaction time will be increased. The two are inversely proportional. In this experiment, you will be reacting potassium iodate with sodium bisulfite at varying concentrations of iodate ion. As we decrease the concentration of potassium iodate, you will notice a change in the reaction time and can determine the rate of the reaction relative to the concentration. You will be looking at whether, based on the concentration, the iodate ion is a first order or a second order determining factor for the rate. This first reaction has 50 milliliters of potassium iodate and will add 5 milliliters of sodium bisulfite solution. The concentrations of these two solutions can be found in the description. You'll be measuring how fast this reaction occurs. The blue color is due to the presence of starch, which will act as an indicator for the iodine molecule generated. Using a second trial, we can figure out the average time it takes for the reaction to occur at this concentration. At subsequent lower concentrations of iodate, you will see the reaction time change as a function of concentration. In the next trial, we are using 40 milliliters of potassium iodate and 10 milliliters of distilled water, while still maintaining a constant 5 milliliters of sodium bisulfite. By holding all but one variable constant, we can selectively determine what change the concentration of iodate has on the rate. Looking at the second trial of 40 milliliters of potassium iodate and 10 milliliters of water, we can get an average for this particular concentration. We again are lowering the concentration of the iodate ion with 30 milliliters of iodate solution and 20 milliliters of distilled water, still keeping the sodium bisulfite concentration the same. You will notice that the reaction time is beginning to take a longer time period. Using the second trial, we can see how fast the reaction occurs as an average between the two. In the fourth concentration, we are using 20 milliliters of potassium iodate and 30 milliliters of distilled water. Upon addition of the sodium bisulfite, we will see a longer reaction time, indicating a smaller rate. At this concentration, the reaction time is now over 1 minute long. Upon adding the sodium bisulfite, we can test the second trial. The last set of reactions will have the longest reaction time by adding 5 milliliters of potassium bisulfite to 10 milliliters of potassium iodate. You will notice that by lowering the concentration by a set amount each time, the difference in the reaction time continually increases. What might not have been a noticeable change between the first and second reactions is now a significant change between the fourth and the fifth. This is because the rate is logarithmically related to the time. You will notice that the color is also quite a bit lighter as there is less concentration of iodine in the end. For the second trial, we should get a similar result. The last reaction will be the longest, with the lowest concentration of potassium iodate. Still adding 5 milliliters of sodium bisulfite to keep the concentration constant throughout the entire experiment. you will notice the time between reactions keeps getting longer and longer. The time difference between the reaction of 50 milliliters potassium iodate and 40 milliliters potassium iodate was very small. Yet, the time difference between 20 milliliters of potassium iodate and the current trial of 10 milliliters potassium iodate, the time difference is very long. This is because time is related to the concentration in a logarithmic way. In the report, you will be plotting the time and the concentration on a log scale. You will also notice the final color of this color change is less dramatic and less concentrated. The lighter color is because of the smaller concentration of iodine being generated. The first trial was close to 3 minutes long before the reaction occurred. This second trial should be similar. In the report, when you plot the log of concentration and time, it should give you a straight line. The slope of this line will be the order of the reaction. A slope of 1 would indicate a first-order reaction based on the concentration of iodate. The reaction order should be the nearest whole number to the slope of your line. When recording the time it takes for all of these reactions, be sure to be relatively consistent in the appearance of when you record when the reaction is completed.